You know, when we want to understand our origins, we usually look up, right? At the biggest things. Galaxies, stars, planets. But what if the greatest secrets of all are hidden in the smallest things imaginable? Today, we're going to crack the code of our solar system's history by thinking small. Really small. We're diving into the amazing story of cosmic dust.
Okay, just picture this for a second. What if you could somehow reach back 4.5 billion years and just grab a little piece of that original swirling cloud of gas and dust that became, well, everything. The sun, the earth, all of it. What would that be like? Well, here's the wild part. It's not science fiction. Scientists are actually doing it. That ancient material, it's out there, floating around and falling towards Earth as we speak. The real trick, though, it's catching the stuff.
So for decades, we've had moon rocks and we've had meteorites. They've taught us a ton. But this is something else entirely. We're talking about a revolutionary third category of material from space, and it's completely rewriting how we see our cosmic backyard.
So let's meet them. They're called interplanetary dust particles, or IDPs for short. Now, these are nothing like the rocks we get from the moon or the meteorites that fall to the ground. They're these microscopic grains, most likely coming from comets, that are constantly raining down on us. And their unique journey gives us a window into the past that we just can't get anywhere else.
Which brings up a pretty big question, right? How in the world do you catch something that small, that fragile? Well, it turns out you need some high-flying jets and a little bit of surprisingly gentle physics. The whole process is just fascinating.
I mean, think about it. Something hitting our atmosphere at 25 kilometers a second, you'd expect it to just vaporize, right? Boof! But because these particles are so incredibly tiny, we're talking less than 10 microns, the atmosphere acts like a big soft cushion. They slow way down, way up high, and most of them barely even get warm. So NASA can actually fly these specially equipped planes up into the stratosphere and just scoop them right out of the air.
And what they pull out of the air, it's just incredible. Because they survive that fiery plunge in one piece. The particles they find are often these beautiful, delicate, fluffy things. The scientist Colin Pellinger had this perfect description for them. He said they looked porous, reentrant, or even like a fairy castle. That kind of structure just screams that it's something really old and untouched.
But, you know, catching these things, that's only half the battle. The real journey begins when we get these tiny grains back in the lab and slide them under some of the most powerful microscopes on Earth.
And to really wrap your head around the scale we're talking about here, you have to hear this quote from the scientist P. Fraundorf. To you and me, a 5-micron grain is totally invisible. But to an electron microscopist, it's this huge, complex world just packed with clues. It's like a field geologist standing in front of a 3-ton boulder.
So, to crack these cases, scientists basically have this cosmic forensics kit. They use transmission electron microscopes to see the particle's internal structure, something called electron diffraction to figure out what its minerals are, and then X-ray analysis to get its exact chemical recipe. It's like a full interrogation of this tiny speck of dust.
And this is where things get really interesting. When they started looking closely at these little grains, they realized something startling. These weren't just identical specks of cosmic dust. Nope. Each one was an individual, with its own history, its own story to tell.
So in this one landmark study, they looked at just 11 of these particles. 11. And what they found was, wow, they weren't all the same at all. Not even close. It was like they'd found 11 different witnesses to the birth of the solar system, and each one was telling a slightly different story. Let's meet a couple of these key characters.
First up, a particle they nicknamed blow-up, for a very good reason. When they just gently tried to handle it, it literally disintegrated into hundreds of little coated silicate grains. That tells you it wasn't a solid rock. It was a fragile bundle of different bits and pieces that had all been kind of glued together a long time ago. Then you've got Oz. This one was amazing. It was packed with droplets of metallic iron and a super rare mineral called cohenite. Now, those things can only form in an environment with very little oxygen. This was a huge clue.
It meant some of this dust came from a part of the early solar system that was totally different from where we think most meteorites came from.
I mean, the sheer variety here is it's mind-blowing. Particles they called zodiac and Chagnar were different yet again. They were mostly what we call amorphous, basically not a crystal, just a jumble of atoms. And they had this really weird sulfur to iron ratio that didn't match any known mineral. It was like discovering a whole new kind of matter.
So you've got all these different particles, each one a total individual with its own backstory. What's the big picture here? Well, it means that these IDPs, they're not just some curiosity. They represent an entirely new branch on the family tree of stuff from space.
See, this diversity is everything. For the longest time, our whole story of the early solar system was built on meteorites. But what if they were only showing us one chapter of the book? What if this dust was telling us the rest of the story?
And when you actually put the IDPs side by side with even the most primitive meteorites, well, the differences just jump out at you. The dust is full of what we call anhydrous or water-free silicates, and it's highly reduced. The meteorites? They're full of water-rich minerals and are oxidized. Their basic chemistry, it's just fundamentally different.
And honestly, what's maybe even more telling isn't just what these IDPs have, like that special metallic iron and those rare carbides. It's what they're missing. The fact that they don't have all those water-rich minerals that are so common in primitive meteorites, that clinches it. These particles are not just little crumbled-up bits of meteorites. They are their own thing.
And all of this, it leads us to the final, and I think most exciting conclusion. These tiny, invisible grains of dust, they're more than just dust. They are pristine time capsules, carrying messages from the very dawn of our solar system.
There's this quote from that original 1981 paper by P. Fraundorf that just nails it. He said that the incredible variety proves these particles are collecting debris from all these different processes that were happening back in the early solar system. It's like a library of cosmic history, written on the tiniest possible scale.
So let's break it down. What are the big takeaways here? First, interplanetary dust is its own thing, a brand new, distinct class of material from space. Second, these particles are unmetamorphosed, which is just a fancy way of saying they are more original, more primitive than almost any meteorite we've ever found. And that means they're our best guess for what pristine material from comets actually looks like.
And that just leaves us with this one final thought. If every single one of these tiny, invisible dust grains is a completely unique message from a different time and place in our ancient past, it just makes you wonder, what other incredible stories are still floating out there just waiting for us to find a way to catch them?